Laws of exponents dividing monomials, lesson 4.3 notes. Example number 4. We're going to simplify each of these. To simplify, you want to follow your order of operations. So we're following PEMDAS. Well, PEMDAS, the first letter P stands for parentheses. That means we want to do everything we possibly can inside the parentheses first, which means the outside exponent will be the last step that we do. The outside exponent will be the last step. Simplify everything on the inside of the parentheses first. Simplify everything inside the parentheses before you do anything. So let's look at example A. If you look at example A, 3/4 is a fraction that does not simplify. Because it doesn't simplify, I simply apply the power of a fraction property. So I'm going to take and I'm going to multiply each of these exponents. So I'm going to have 3 squared in the numerator and 4 squared in the denominator. Well, 3 squared is 9, and 4 squared is 16. And that's all the farther we can go on that problem. Again, 3/4 squared becomes 9/16. Okay, let's look at B. Again, we want to follow the order of operations. So we want to do what's inside the parentheses first. Well, 10 divided by 5 is 2. So this is going to be 2 to the 5th power. If I do 2 to the 5th power in my calculator, pull up the calculator here. Two to the 5th power is 32. So this would be 32. Okay, so now I'm going to show you why you want to do what's in the parentheses first. So I'm going to do the same thing, except this time I'm going to go ahead and just apply the outside exponent first. In other words, I would take 5 to the 10, so this would be 10 to the 5th power, and then on the bottom, 5 to the 5th power. So again, I'm going to show you why it's much better to simplify what is in the parentheses first. Okay, so 10 to the 5th power is 100,000. And guys, I taught you, if you remember in the first lesson, when you take 10 and raise it to a power, whatever the power is, that's how many zeros there should be. Since the exponent was 5, I have 5 zeros. Okay. 5 to the 5th power is 3,125. So let's divide those out. You get 32. So did we get the same number? Sure, we got the same number. However, it was much easier to simplify what was inside the parentheses first. It was much easier to use this method. So that is why I'm begging you to please do everything inside the parentheses first before applying that outside exponent. All right. For C, can I simplify what's on the inside? Well, the numerator has a base of x and the denominator has a base of y. You can't simplify that. The bases are different. Remember, you can only divide when the bases are the same. So the only thing I can do on this problem is multiply my exponents. So in the numerator, I'm going to have x to the 9 times n is 9n. And in the denominator, 9 times n would give me y to the 9n. And again, these numbers, or these bases, are different, so I can't simplify. That means that's all the farther I can go in this problem. Okay. So for each of those, I simplified what I could on the inside, and then I applied the outside exponent. Let's do that on D. Okay, well, if I want to simplify what's on the inside first, that means I'm going to need to divide first. Go ahead and put a 1 on that x. I need to divide first. So in my calculator, I'm going to put -6 over 3. That's -2. Remember, when you get an integer, that goes in the numerator. So the -2 would go in the numerator. X to the first has the smaller exponent. Let's cross that out. 2 minus 1 is 1. Y to the second has the smaller exponent. Completely cross it out. 4 minus 2 is 2. Z to the second has the smaller exponent, so I completely cross that term out. 3 minus 2 is 1. Okay, so there's nothing left in the denominator, so that means all of this is just a 1, which means I don't need to write it. So instead, I just need to write what was left in the numerator. And in the numerator was -2, x to the first, y squared, z to the first. And all of that is still to the 4th power. Now, the reason why I kept the exponents of 1 is because I'm not done. This isn't my final answer, so that's why I kept the 1s. If it were my final answer, I wouldn't write x to the first, I would just write x. But because I'm not done, I go ahead and I write those 1s. Okay, did I simplify everything inside the parentheses? Yes. So now that everything's simplified inside, following my order of operations, I got to do what's outside the parentheses, which is that exponent. So this is like we did in lesson number 2, and this is a power of a product. This is power of a product. So the first thing I want to do is I'm going to take that -2, I'm going to put it in parentheses and raise it to the 4th power. So in my parentheses, I put -2, and I'm going to raise that to the 4th power, and I get 16. To finish this, you draw your rainbows. So I'm going to take 4 times 1 to get x to the 4th. Then I'm going to take, try to give it a different color here. There we go. I'm going to take 4 times 2 to get y to the 8th. Then last, I'm going to take the 4 times the 1 to get z to the 4th. And now I am finished. Okay, so what I did I did what was inside the parentheses, and then I applied the outside exponent, which, because there was no fraction left, it was just power of a product, to get 16, x to the 4th, y to the 8th, z to the 4th. I'm going to stop the video after that example. I'll do E and F in a different video. If you have any questions so far for example 4, please do not hesitate to ask.